Stage, Doug Berger from Microsoft Research. Doug?
Thank you, Satya. I have to say I'm really excited to share this with you today. As a company, we've been on a journey to develop the world's most intelligent cloud. Now, we already have industry-leading capabilities with our Azure GPU offering, which is fantastic for building trained AI models offline. Okay, but to support live AI services with very low response times at large scale, with great efficiency, better than CPUs, we've made a major investment in FPGAs. Now, FPGAs are programmable hardware. What that means is that you get the efficiency of hardware, but you also get flexibility because you can change their functionality on the fly. And this new architecture that we've built effectively embeds an FPGA-based AI supercomputer into our global hyperscale cloud. We get awesome speed, scale, and efficiency. It will change what's possible for AI. Now, over the past 2 years, quietly, we've deployed it across our global hyperscale data centers in 15 countries spanning 5 continents. Okay, so let's start with a visual demo of what happens when you add this FPGA technology to one of our cloud servers. We're using a special type of neural network called a convolutional neural net to recognize the contents of a collection of images. Okay, on the left of the screen, what you see is how fast we can classify a set of images using a powerful cloud-based server running on CPUs. On the right, you see what happens when we add a single 30-watt Microsoft-designed FPGA board to the server. This single board turbocharges the server, allowing it to recognize the images significantly faster. It gives the server a huge boost for AI tasks. Okay, now let's try something a little harder, using a more sophisticated neural network to translate languages. The deep neural network-based approach we're using here is computationally much harder. It requires much more compute, but it's achieving record-setting accuracy in language translation. Okay, so to test the system, let's see how quickly we can translate a book from one language to another. Now, I picked a nice small book for this demo, War and Peace. It's about 1,440 pages. And we'll go over to the monitor here, and using 24 high-end CPU cores, we will start translating the book from Russian to English. Okay. Now we'll throw 4 boards from our FPGA-based supercomputer at the same problem, which uses a 1/5 less total power. As you can see, thank you. We're not done. As you can see, our accelerated cognitive services run blazingly fast, 8 times faster, while using less power. These 4 boards can translate War and Peace in just 2.5 seconds. But even more importantly, we can now do accelerated AI on a global scale, at hyperscale. Now, Satya's a big reader with a big personal library, so we thought about translating his library. But the thought of sneaking into my CEO's house, scanning all of his books, and getting out without being caught wasn't so attractive. So we thought about, what's a different store of text that we can translate? We decided to go to Wikipedia. Now, English is the largest language in Wikipedia. It has 5 million articles, about 3 billion words. If printed on paper, it would be a stack 1/4 mile high. So if we threw the same 4 nodes, running around 8 trillion operations per second at the problem, as you can see, it would take nearly 4 hours to grind through that 1/4 mile stack. Now, of course, we have this fabric, which is global and hyperscale, so we could easily throw 50 nodes, 50 FPGA boards at the problem, which would take us up to about 100 trillion operations per second, and of course, bring the time down further. But to show you the raw power of this hyperscale AI supercomputer that we've embedded in our cloud, in our global cloud, I'll show you what would happen if we decided to throw most of our existing global deployment at it. Okay, let's go all the way over here and see how fast we could go. Less than 1/10 of a second. we could translate all 5 billion words into another language in less than 1/10 of a second. Now, some of you may have blinked in surprise when you saw that result, and you may or may not know that it takes a human being about 2/10 of a second to blink. So we can actually translate those 5 billion words, if we threw our deployment at it, in less time than it takes to blink once. That's hyperscale acceleration. That crazy speed shows the raw power of what we've deployed in our intelligent cloud. Okay, so now what does it mean? You may have noticed on the screen that we are running at over an exaop, again, if we threw our whole deployment at it. What does it mean to be at exascale? That means we can run a billion operations per second. It means we have 10 times the AI capability of the world's largest existing supercomputer. It allows us to do things on a scale that hasn't been done before. We can solve problems with AI that haven't been solved before, the things that weren't even possible just a few years ago. Okay? We're already porting some of our cognitive services to run on this fabric. Now, this FPGA-based fabric that we've built is very flexible. Okay? So Azure already announced today that they're using it to provide their accelerated networking, the fastest cloud network, industry-leading cloud network, running 25 gigabits per second at 10x reduction in latency. So this fabric that's been deployed in between our servers and our network can be used to run the world's most powerful AI. It can be used to run the world's fastest cloud network, or both. So it's providing leadership for cloud networking and potentially for AI. When you do a Bing search, you're already touching this fabric. Bing ranking is running on it. While many companies are experimenting with much smaller scale bolt-on systems, Microsoft is the first to have its global hyperscale cloud enhanced with post-CPU technology, in this case, FPGAs. It gives us the most powerful cloud, the most flexible cloud, and the most intelligent cloud. And we're committed to using it to support and empower you, our partners and customers, as we move forward into the